Would you like to play a game? Actually, no game, just going over probability of unions and how they exist within probability and statistics. Now, by StatTrack.com's definition, the probability of the union of events A and B is denoted by the following. If the occurrence of event A changes the probability of event B, then the events A and B are dependent. On the other hand, if the occurrence of event A does not change the probability of event B, then the events A and B are independent. This sounds great. However, I think there's an easier way we can break this down. Okay, so let's go into the following example. Think of these unions as a set of lists. Each list has a unique item that are to be gathered for a Thanksgiving meal. Although these lists might be coming from two different people, there's a chance that there are some ingredients that can be on both lists. Okay. Now, if we just simply take a look at the list, we can kind of pick and choose which ones, or at least where our redundancies are. However, thanks to unions or probability of unions, we're able to do this mathematically. Okay, so from the Thanksgiving list, let's turn our definitions around or our words around. So let's turn the lists into events. Okay, events and sets can be used interchangeably here, and also let's turn the ingredients into numbers. Okay, so from the original list once we have sets. From the original list one or sets, we have 1, 3, 7, 9, and 12. And from the second set, we have 2, 3, 7, 8, and 12. Okay, and so from these sets, let's go ahead and throw in this formula. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. So probability of A is actually going to be our first set plus probability of B, which will be our second set. Now, when the subtraction of the probability of A intersect B, what this portion defines are the duplicate items from that original list. So one thing to also note here is that if we count, there are a total of 10 individual or unique items. Now, of that, the first set has 5 total. The second set also has 5. Okay, so the next part of our equations is the next part of the equation is to identify the items here that are duplicated and do the following. Okay, so we have 5 over 10. Again, the 5 represents the first set over the total amount of items, which is 10. So 5 over 10, that's going to be our P of A. And the second set is going to also be 5 over 10. This is also will be represented of P of B. And we're going to subtract the intersects or the redundancies. In this case, there are a total of 3 redundancies, both 3, 7, and 12. Okay, if we add the algebra to that, we're going to get 7 over 10 or 70%. Okay, so to summarize this, from our definition, these two sets were dependent because both had the same items in each list. However, we were just tossing a mix-up. Just say we had one of our lists and we had a whale. Well, these two events would be independent because, well, one's a whale. And this means that they have no correlation, or there's no correlation between the two sets. So hopefully this sheds some light on probability of unions. Some real-world examples would be, well, this said list, but another one would be, just say a distribution house wants to know the different items it has throughout its warehouses in America and wants to figure out the probability of what to stock up and what not to stock up. Well, something like this would ultimately be added into that equation. Okay, some of my resources are the Khan Academy, Star Trek, StatTrek.com, and our course textbooks. Okay, hopefully this has been a decent introduction or analyzation of probability of unions. And with that, have a happy and safe Halloween.